Hi everyone. Last lesson we're looking at measures of central tendency, and I gave you these data sets to work out the mean and the median with. Apart from the first one, what we should notice is that the last five there all ended up with the mean of 3 and a median of 3. So according to the central tendency, there is no statistical difference between them. But if we actually look at their numbers, you can see D is all threes, B, apart from the N's, are threes, C has all five are different numbers, and so on and so on. And if you look at F's extreme values there, so all data set is different, but the statistics we have make it look like our data is exactly the same. So we need more statistics. We need another statistics rather than just looking at the middle, because the middles of those data are the same. We need to look how they vary. And that's when we come to something called the measures of spread. So how the data varies is really important in distinguishing features within a data set. So one measure of spread that you should be familiar with is looking at the range. And the range is simply the maximum number take away the minimum number. And the max min is just one way of saying the highest value and the lowest value. So simply, if we want to see how the data varies, that we can take those values and take those values away from each other. So what I want you to have a go at this time is with the same data set. You'll notice I've added an extra column. So I want you to work out what the range is. So just in case you weren't sure, the max is the highest number and the minimum is the lowest number. So for A, it would be 20 take away 2, which gives us 18. So if you could spend some time doing that, just pause the video and then we'll put the answers up. So hopefully you pause the video and you've got your answers. So let's see whether they're right or not. Here are the ranges of all the data sets. So let's go through them quickly. So we've already talked about 20 take away 2. 5 take away 1 is 4. 5 take away 1 is 4. 3 take away 3 is 0. 6 take away 0. And 200 take away minus 194 gives us 394. So you can see now that once we've included the range or the measure of spread with our mean median there, we suddenly have statistically different data sets. And the easy thing to say is that the least varied has the lowest range, and the most varied has the highest range. So suddenly, without looking at the data set, we can get information like that. And we can expand that to bigger data sets of, say, instead of 5 and 6, of 5 data points, we can do that for 200 or whatever. So we can get an idea and compare data sets to see what's going on. However, there is still an issue that we have, is that you'll notice B and C have the same range, even though they are quite varied data sets. You can see that 3, if we look at the middle, you can actually see that those values are, B and C, if you look at those middle values, it's the extreme values that are the same, not the ones in between. So in the same way that the range is a quick and easy way to be able to give us a measure of spread, it is affected by those extreme values in the same way that the mean is. So we need another value to also use in conjunction with that to give us a better idea of what's going on. And again, it might be something that you're already familiar with, and that's something called the interquartile range. Now, put relatively simply, the interquartile range is equal to the upper quartile take away the lower quartile. And the upper quartile just represents 75% of the values. The lower quartile represents the lower 25% of the values. So in other words, rather than with the median dividing our values into half, quartiles use the data divided into quartiles. And these are the ones that represent the point where the halfway in the lower part of the median and the halfway in the upper part above the median. So another ways we can talk about it is IQR is equal to the upper quartile take away the lower quartile. So how do we measure it? I'll show you some examples. So we've got 3 data sets here. First thing we do with all the data sets, starting with A, we find the median, so it's got to be ordered from lowest to highest. The next thing is to follow the process that we cancel our way to find the middle. So doing that finds that the median is in between 20 and 21. So we should know by now that halfway between 20 and 21 is 20.5. Now what we do is find the median of the lower group. So we split the data in half, and the lower group is represented by this part, which is the 12, 14, 17, 20. And basically what we try and do is find the median of that half, which gives us a median of 15.5. Now we repeat the process with the top half, which is 21, 21, 21, 26. So cancelling your way to the middle, and you end up with a median of 21. So what that means is we've ended up with a lower quartile of 15.5, an upper quartile of 21. So it means the interquartile is going to be 21 take away 15.5, which gives us a lower quartile of 5.5. Right, with example B, first thing, like last time, make sure it's in order from lowest to highest. Then the next thing is to find the median, and then work your way into the center, and this time the median is equal to 7. Now you'll notice that we end up getting a number for the median rather than having it between 2 numbers. That's because we've got an odd number of values in our data set. So the key part for what that means for the next part is when we're looking at finding the median of the lower group, is that we make sure we don't include the median in our lower group. So the low group in this case is looking at from 0 all the way through to 6. And then we can work our way to the center to find 3 as our lower quartile. Now to find the median of the higher group. So again, we don't include the 7. So this represents the higher group. So you cancel all the way to find the center, which is equal to 9, which has a median of 9. So that means the lower quartile is 3, the upper quartile is 9. So therefore, the lower interquartile range is not equal to 23. It's equal to 9 take away 3, which is equal to 6. So moving on to our third example, make sure our numbers is set up from lowest to highest, find the median, work our way to the center. It's 52. So that means our lower quartile is, our lower group is 45 and 47. Our higher group is 61 and 77. So we can find our median, which halfway between there is 46. And the upper group is 61 and 77. Again, cancelling to the middle, which has a median of 69. So it doesn't have to be that they're next to each other. And the easiest way to calculate that number is that we go 61 plus 77 divided by 2 to find our number halfway. So it's like taking the average of just those two numbers. So the lower quartile is 46, the upper quartile is 69, meaning that our interquartile range is equal to 23. And it was right this time. So now to summarize, when finding the upper and the lower quartile, first thing we need to do is make sure it's ordered from lowest to highest. Second thing is find the median. The third thing is to find the lower quartile as the median of the bottom half, while the upper quartile is the median of the top half. And the easiest thing to think about it, or the easiest way to think about it, is you should end up with 4 equal groups. Because they're quarters, they should all be the same size. So whenever you do it, you should end up with 4 equal groups. So there are 2 numbers between each of the statistics. And the last thing is that they represent a percentage of the data. So the key thing with the median is that 50% are above and 50% are below. Where the lower quartile, only 25% of the values are below, and with the upper quartile, 75% are below. You can also reverse that and say there's 25% above the upper quartile and there are 75% above the lower quartile. So the key thing with all the data to calculate the range, it's the maximum take away the minimum, and the interquartile range, you take away the the lower quartile from the upper quartile. So going back to our data set here where we had the issue that B and C had similar ranges and similar means and medians, I wonder, let's have a look to see what the actual interquartile range, how that changes the statistics of each of the data set. So pause the video and then have a crack at getting an answer. So pause the video now. So hopefully you had a go at working out the numbers. Let's have a look what they look like. So here are their interquartile ranges. So let's have a quick look how we work those out. Because there's 5 in the data set, it does make it really easy to work out the upper and lower quartiles. So 12 take away 7 is 5. That's good. 3 take away 3 is 0, so that's right. 4 take away 2 is correct. 3 take away 3 is 0. 4 take away 2 is correct. 5 take away 1 gives us 4. So what we've now got, the interquartile range works in the same way as the range. The bigger the number, the more varied. So you can see that we're saying that A has got the most variation in the interquartile range, and followed by X, then C and E, and then lastly B and D. So what we now, between our 4 statistics that we have, we now have a different statistical picture for each one of those data sets. There is no common statistics, because, and nor should there be, because the data is all different. So using the statistics, we can see that this data is different, and then we can see features within it. And that's kind of the point. So that's the end of this lesson. If you want to go onto your OneNote, there should be some questions from the workbook which you can complete.